Hello everyone, thanks for joining my presentation. This thesis is for the Master Degree of Sustainable Development and its topic is lithium production in the future and its impact on the EU. My supervisor is Professor Valentin Chu and my subject reviewer is Professor Mika Hawk. Okay, those are three rules I use to guide my research. The first one is numbers should be a way of helping us to understand the reality rather than simplify it. Because this is a quantitative study, so we need to understand what those numbers mean for and what's the limitation of that, and we try to avoid the misunderstanding of the result and describe the reality in a right way. And second one is the extractive industry is an essential part of human society, which reflects our attitude towards nature and each other. Uh, yes, this is an industry and part of our society which responsibility for the uh, uh, interaction between human society and nature. And yes, but now it's not being exposed to everyone because the society has different segments, but it is always along with us, uh, and also how it's work is decided by our system. So I put it in this is the attitude towards this industry is this industry is decided by our attitude towards nature and each other. And the third one is the future can be predicted, but is yet to be decided. Yeah, like I like science fiction, in which there is not interesting discussion about the future. Is that I mean we need to answer is this uh, study can describe the future, or we really predict the future? And yeah, this is interesting thinking. Next. Okay. Uh, this is a minor intensive transformation ahead of us, and the mining industry should be a concern. This is the reason. The EV cars has 5 times material demands than the conventional cars, and we also have some green technology which require lots of minerals and metals. Those green technology lead us to the scenarios. This is a sustainable development scenario, and this is net zero scenario. And in SD scenarios, by 2014, we can see that the metal consumption will be 4 times more than it is today, and it will be 6 times in net zero scenarios. And right side, we can see compared to the 2020, the lithium will be 14 times more than the current consumption in the SD scenario. This is the reason why we need to lead to those transformation, because decarbonization and reduce greenhouse gas emission. And this is a current where the currently where are minery from, and we can see here most of them come from Asia and Oceania and Latin American and Africa, and a little bit from North American, and very seldom from Europe. And in terms of the electrification, uh, Harrington, he conducted research. He calculates the lithium consumption for switching the UK's conventional car to the EVs, and the lithium requirement is 49 kilotons, which is half of our current global production, just for the UK. So our research question, and first, what is possible future lithium production looks like? We will answer it with uh, quantitative study, and the second, what is distribution of lithium resources and the productions, and we separate them to briny and hard rock deposits. And third, what is the global lithium supply and demand? How will it impact sustainable development? And four, how can the European Union to satisfy its own needs in a sustainable way? Methodology. First, we use curve fitting models to extrapolate the future lithium production, and those are what we use. The first one is logistic function, and the second one is compass functions. Both of them are based on the idea that our groups have patterns and subject to the natural laws. We should remember that the production is like the final result of the driving force and the hindrance. So it's not uh, just counting one side, but it's and the final result, hindrance and obstacle and driving force. And second, we need to know that logistic functions and compass functions have different interpretation on gross inertia, which is contained in the empirical data. And three, these two functions are widely used in describing and predicting energy resources production, the growth of thermal and demographic studies, and also in pandemic stimulation. We will say that here are two functions, two curves. This one is compass curve, and this one is logistic curves. And we can see that based on same data, compass curve have much lower prediction than the logistic curve. So we can say that compass curve, compass scenario is stand for one scenario that with more hindrance. And this is an example. People use compass curve to predict the COVID-19 infection, and based on the real-time data, so you can see how those functions capture the inertia in the real-time data. And data preparation. First, we collect the data from United States Geologic Survey and British Geologic Survey. We set up a database of lithium production data in 32 countries since 1920 to 2020, and we combine two different data sets, and the search creates one pair of aggregated scenarios and three pairs of disaggregated scenarios. You can see in the right side, scenario A is global resources, so it's aggregated results, and B, C, D are disaggregate scenarios. B, we break down the lithium by deposit type, and in C we break down them by locations, and D we break down them by deposit types and locations. And four, there is two key elements. One is ultimately recoverable resources (URR), and the other one is historical annual production. Um, it need to mention that URR is the definition of URR is kind of resources we are known, and it's economic and in the future, but the definition of the future is not sure. But mostly maybe in 15 years. Okay, there is some limitation and uncertainties in our study. And first, uncertainty in the model. Um, because prediction curves relies on the quality of empirical data, and what we use is the most reliable data for now, but we need to understand that they are not necessarily be very accuracy. Mm. And second, the potential growth on resources could change the result, um, because lithium resources is experiencing a growth, which is driven by the financial market. So we should see some increase in the future. And third, lithium consumption is simplified in this study because we only included the EV's demand, but there are also some other demands, other technology which requires lithium, such as robots and drones and smart device. And second part is uncertainties in the supply chain. First, we should notice that other critical minerals could fall in shortage, thus affecting the lithium demand, like cobalt, nickel, and graphite, because without them, we still cannot produce batteries. And second, the impact of COVID-19. COVID-19 is actually affecting the production in resource export countries now, and many mining companies has lowered their expectation for the future production. That could be an issue for the short term. And the third, technology change could happen. Like we have some alternative battery technology, and we also have different technology for the energy fuel, like hydrogen fuel cars. So by those technologies, we can reduce the lithium consumption. And this is lithium background information. And left side, we can see here is a hard rock deposit. This is Greenbush in Western Australia. and this is briny deposits in Chile, and yeah, they are distinguished in terms of geologic, economic geology perspective, and this is how they are so different, and you will see different components in different shares in the cost. This is a briny cost, and this is a hard rock cost, and it's very different here, like reagents, like most almost 14% of the costs come from reagents in briny and brine, and in hard rock it's almost invisible. So there is three elements related to the deposit types, and three of them related to the geographic location. This is why we want to separate them, because they stand for different situation. And this is lithium resource distribution. It's so different if we look at the lithium resources in terms of two deposit type. And 16% of the lithium resources located in Latin America, and most of them are brine. And from here, we can see 68% of the lithium resources are brine, 32% are hard rocks. And you can see here, the green dots are hard rock lithium deposit, and the blue one are brine deposit. And from the geological diverse hard rock lithium resources is more diverse in terms of the location. This is the reason they can expand quicker than the brine lithium resources. And this is lithium history production and consumption. And this is production here. We see, and now Latin America and Oceania are two major producers of lithium, and our major consumer are China, Europe, and the US. So we can see there is increasing trade here, along with production increase. And 67% of these things are for battery industry, but aside from it, we have other industries here. This is an overview of our global lithium production models. This first is historic lithium production we saw before, and this is our aggregated scenario based on the global lithium resources. And it's very interesting because you see here before 2015 they are quite similar, and scenario B, we break down by deposit types, and you see they're so distinguished after 2030. And yeah, I think this is our most ideally scenario. And scenario C, break down by geographic locations. Here we see a little fall here. It's because it reflects some uncertainty in the supply chain. And scenario D. This is a scenario most attached to the reality, not uh, most attached to the how to say its current production situation. So you will see it's so different with other scenarios which are very high in peak production. Okay, what we can see from these scenarios, we can see a stable platform of 400 kilotons, and from 2014 and last almost 100 years. And this one is our ideal scenario because it supports long time peak production here around 900 kiloton per year, and it can catch up with emerging demand before 2014. So it's almost the highest scenario we can expect. Let me look. Let's look closely, and here are compass curve scenario, and here are logistic scenarios. So, but we should notice that uh, only one scenario, scenario B, will surpass 400 kilotons per year by 2014. So that shows, I mean, large uncertainty in the supply system. And in terms of different deposit type, we disaggregated by deposit type here, and this is original one, scenario A here, and those are scenario B, and this area is hard rock production, and those are bright uh, production. So from here we can see before 2015, most of global lithium production will come from hard rock mining, and after that, the bright lithium production starts to pick up and dominates the supply chain. So which reflects that the hard rock mining is very crucial for the near future, and the bright lithium mining is very crucial for the future after 2015. And this is our ideally hard rock production scenario. With it, we can surpass 400 kilotons per year by 2014. And in terms of geographic locations, Australian lithium production is the pillar for supply chain before 2050. You will see most lithium will come from Australia, and Latin American will take up most lithium production since 2050. So you will see the green part here and here. This is analyzed for the scenario, and we see that here this row is a compass curve, and these rows are logistic curve, and this line is hard rock lithium production. This is bright lithium production, and combine them, we get the global lithium production of scenario D. So you see, compared to the scenario B, there is so many voids, and we will analyze how it's be created. And in total, in compass curve, it's there is a 400 kiloton per year voids, and for the logistic scenarios, uh, there is 600 kilotons per year gain. So we are going to figure out why. Uh, and left sides, they are brine lithium production scenario, and the right is hard rock. In brine scenario, there is 15% of the brine lithium production, brine lithium resources don't included in the start in scenario D. It's because Bolivia, the United States, and Germany, they don't have any production right now. So if there is no production, the function cannot give the curve. But yeah, it's not just mathematical problem, but it's also reflects some problem in the production side, because we know the Bolivia has severe geopolitical problem, and Germany also have very strong resistance for the mining activity. So this is the reason why they don't have any production right now. And the right side, there is 17% of the resources located in North American, Latin American, and Europe, Africa. They don't have many. They don't have massive production right now. This is why the curve predicts their peak year will come, and 2001 is quite far from now. So we create what if scenario to explore the possible future. And the left side, we can see we assume that Argentina will expand the production like Chile did. So the curve shifts from here to here. And the right side, we assume that the EU will expand the production in the near future, and Australia. So the production of EU will change from here to here. And we see some of the blank place has been filled by those change. And compared to the global scenario, this is a new one, and compared to the old one, there is 300 kilotons per year differences, and we can say that the EU will be an essential producer for from 2014 to 2016, and which is very important for the green transition. And the second one, we can see that even the EU and Argentina can expand the production, and they will not change production before 2014 significantly. You will see here there is not too much change here. And this is lithium future consumption scenarios. We use scenarios from IEA, International Energy Agency, and they gave two scenarios. One is sustainable development scenario, and the other one is stated policy scenarios. Stated policy scenarios is based on the current policy for the green transition. So they need two different material consumption. And the right side, those are factors we use for predicting the future consumption by 2050. And yeah, the most important element is here. We assume that recycling ratio will be 75 percentage by 2050, and it started from the 10 percentage in 2030. Those are comparisons, and first we notice that SD scenario will surpass all our scenarios before 2013. So it's quite big different in compass curves, and here is logistic curve scenarios. And in right side, we notice that most of scenarios predict the yield will be from 0.4 million tons to 0.8 million tons per year by 2050. And the blue bar is uh, those blue bars are uh, from different studies. They are like no lithium demand case, and the green bars, they are like high prediction of lithium consumption. So we can see our scenarios just covered part of the no lithium demand prediction, and this is the what if scenario in the calculation, and it can reach like 1 million tons per year by 2050. And how it will impact the EU, we see here. This one is EU's lithium consumption. This is the real data. This is real data, but this is the prediction curve, and those are our production scenarios, and this is historical production data. So that you can see there is like huge demand and huge gap between demand and supply. So I try to introduce the what if scenario, and in which we can see that if the EU can expand its lithium production, it could be able to cover half of the lithium consumption by 2030. And we'll also notice that even if the EU expands its lithium production, it still needs 15 years to reach the exponential increase point. Yeah, basically it's where the EU can expand its own production in a very fast pace. Okay, let's get into the discussion part. And left side, we have supply problem, and the demand sides, we have some elements driving those material consumption. And supply side, we have a sustainable challenge in supply chain, which includes politics, environmental, and economic. And we also have some supply insecurity problem in a short time and long time, because you remember the scenarios, and first we need to address one problem. It's the lithium consumption grows too fast in before 2015, and in long term we see that Bolivia, which has a large amount of lithium resources, have problem with because of the geopolitical challenges and also environmental challenges. So what we can do? Uh, First, of course, increase the yield and to reduce the demand. So this slide is a framework of how we can mitigate those problems. And first, we need a global sustainable supply chain system here to address those sustainable challenge in the supply chain. And it also can secure our raw materials supply in the future because if it can address the problem in Bolivia and Latin America, and we find the right way to address those problems or mitigate those problems so they can go to production scenarios. And the second one is diversify the hard rock production. This is especially for the short time challenge because as we know, uh, hard rock mining is the one we can expand in a very fast pace, but that needs more supplier in the future rather than depend on only Australia. And we also have some post. We also post. We also can increase the resources by exploration because the hard rock lithium resources is not like bright lithium resources like the traditional mineral resources. It's the deposit is rather smaller, and because there is no such huge interest in lithium before, so we still can discover more lithium by exploration work. And the demand side, we can have we can introduce like alternative battery technologies, and we also can reforming our transportation system, like make the public transporting public transporting system more efficient and affordable and accountable. So maybe people can shift from their private car to the public transportation. And third, establish recycling system. This is very crucial for the lithium. It can lock a large amount of lithium. In our studies, yeah, like if we can reach 75% of the lithium recycling, we can lock like we can actually it's double the lithium metal in our system, so it's very crucial. And we can expand the life expectancy of batteries. This is a way to reduce the consumption, and we still can change our lifestyle, like do more biking rather than driving. And in terms of EU, I think the EU can be a consumer and a supplier at the same time because first, it has resource available. 9% of global lithium resources located in the EU, which is more than Australia, which is most important supplier of lithium now. And second, there are huge foreseeable demand, like green transition, green recover plan, and so on. So there is demand, markets is there, and third, EU has an advantage in terms of infrastructure and the stable legal system and the skilled workers and the financial markets, which is preferable for the uh, minery industry, and this is the reason why it can expand its lithium production in Australia, because you have those uh, elements, then it's more easy for the expansion. And fourth, it can foster the emerging battery industry because it's reduce transportation and also reduce the cost, and it fosters the industry ecology and raw material security, and its product provides a sustainable product which is uh, subject to the EU's new industry standards. And five, it can reduce the sustainable burden in global material supply chain. First, it's reduce transportation emission, which maybe account for around 20% of the greenhouse gas emission in the life cycle assessment. And we can put better life cycle management of the product, like because if you have industry here, it will be much easier to establish the recycling system, and we can put less environmental pressure on North American because you see the supply system before, and in Asia and North America they have their own lithium production, but European relies on the North American, which means if the EU don't want mine in the bordering in its border, and it must relies on the lithium from North America. And six, the global supply chain is inevitable because from the what if scenario, we know that even if the EU uh, have expanded its production now, it it still cannot cover all the uh, lithium consumption by 2030, and uh, yeah, the EU still needs half of the lithium from outside. So this is the reason we need to maintain the global supply chain. And thanks. First, I want to thank my uh, um, supervisor, Professor Valentin Cho, and my subject reviewer, Professor Mika Hawk, who provides me very interesting topic and give me a lot of support during the research. And I would like to thank my family. Without them, I simply can finish this. And I also want to thank my classmate. Uh, yeah, I would say it's quite good time in Uppsala. In the last 2 years, we have very good memory here. Thank you.